Well, hello everybody. So I am going to make a video on this problem right here, which at least at the time that I'm recording this is question 8 from my math lab assignment 3.2. But this question is fairly involved, all right? There are a lot of numbers. I would imagine that it could be easy to get lost in it. So I thought that in addition to making a video to directly solve this problem and show you how to make your way through it, that I would do a more basic example with numbers that I'm making up on my own, just to illustrate the idea that you'll see in this one, where this is a big problem. There's lots of stuff in it, lots of numbers, lots of possibilities. This is the same idea with this basic example. It's just simpler. So hopefully it'll be easier for you to see what's going on if you try to solve this problem or if you watch the video of me explaining the solution. Okay, so I'll call this a basic example of a sampling distribution. So here's the idea. You have a population of some kind, okay? And what do we do with populations? We take samples from populations. So say we take samples of size n, some predetermined size. And suppose also that we calculate the mean of each sample. That goes by x bar, okay? So the mean of the population goes by the Greek letter mu, and the mean of a sample goes by the symbol x with a bar on top of it, which we just call x bar. So I'm curious to explore now, what is the nature of the sample mean x bar? What is that number going to be like across all the samples, okay? And the prediction is that if I take every conceivable sample of size n from the population and calculate the sample mean, x bar, the collection of all those x bars themselves will have a mean that turns out to be the same as the population mean, okay? And a standard deviation of sigma, the standard deviation of the population, divided by root of n, where n is the size of the sample. So that's the big thought process. Those are the concepts that are involved. And this last step is a prediction about what the collection of all the x bars are like. Okay, so let's try it out. I mean, because that's what this question, that's the force behind it, is that you can have a population and explore all the possible samples of a whatever size, okay? All right, so here my population, I just picked 3 numbers. I want to keep it simple so that we don't get lost in the numbers. 1, 5, and 6, that's my population. Now I've done a little math and I'll show you how I did this in a minute. For this population, the mean mu is 4 and the standard deviation sigma is 2.160247, okay? All right. Now, in order to explore this idea of a sampling distribution, meaning what it's like to look at all samples of a certain size and the mean of each sample and look at all those sample means and see what they're like, my prompt for you is that I want to look at all samples of size 2 and of course the sample means, okay? Now, when we say all samples of size 2, we mean that we're going to pull 2 numbers from this population with replacement. All right, so I'll explain what that means. So I could pick 1 and 5. I could pick 1 and 6. I could pick 5 and 6. But I could also pick, instead of a 1 and then a 5, I could pick a 5 and then a 1. Instead of a 1 and then a 6, I could pick a 6 and then a 1. Instead of a 5 and then a 6, I could pick a 6 and then a 5. So there's like every conceivable way to pick 2 numbers from this population. But remember I said that we'll pick the numbers with replacement. So it's like I pick a number, I put it back, and then I pick another one. So I could pick 1 twice. I could pick a 1, put it back, pick another number 1. I'm just picking them blindly. So I could pick 1 twice, I could pick 5 twice, and I could pick 6 twice. So here's what we're saying it would look like if you take every sample of size 2, okay? Now the sample mean, okay, here's all the samples of size 2, every conceivable sample of size 2. What's the mean of the sample that has a 1 and a 5? Well, so here I use a handheld calculator to do it. So how do you find the mean of a group of numbers? You add the numbers together and you divide by how many numbers there are. That's if you don't use StatCrunch or Excel or something like that. So I take 1 plus 5, that's 2 numbers, so 1 plus 5 over 2, that's 6 over 2, that's 3. So that's how I got all these sample means. 3, 3.5, 5.53. So I'm curious, is the prediction true? What was the prediction? That if you look at all the X bars, like you got all these samples of whatever size, and then you calculate the sample means, you got all these sample means, then the sample means themselves will have a mean equal to the population mean and a standard deviation equal to the population standard deviation over root sample size. Is that true? I mean, at least when I was in college, I was learning things. Yeah, I'd read all this stuff and predictions, equations, and so on, but it just didn't stick in my brain unless I tried it out. So that's kind of what I'm doing with you right now. Is that, look, I got all these numbers. Is the mean really going to be equal to the population mean, which I had already calculated to be 4? And of all these sample means, 3, 3.5, 5.5, is the standard deviation going to be equal really to sigma, the population standard deviation, 2.160247, over root n, where n is the size of these samples, which is 2, and that's 1.528. Is that really true? Can I demonstrate that that's true? Because that's what the prediction is, that's what it says, okay? So we could use StatCrunch to find the mean and the standard deviation. Or, you know, I use StatCrunch a lot, and I think once you get beyond the class, you'll probably use Excel. Excel is such a common tool that people use to do so many different things that every now and then I like to mention Excel. So here's the code, the syntax that you would use to do these calculations. My population was 1, 5, and 6. If you do average, see like this, average, and then you drag on these columns, then it'll find the average of those numbers. That's what we've been calling the mean in our class. In Excel, you type average. If you type stdev.p, so like right there, like that, that will give you the standard deviation of a population. Okay, now some other fine print that the standard deviation of a sample and a population are different. In my video where I solve this problem, I'll explain how you can use StatCrunch to find the numbers that you want. Alright, but for now I'm going to use Excel. Okay, so for the population 1, 5, and 6, the mean is 4, okay, and the standard deviation 2.160247. Alright, so that's how I got, you know, that. Alright, I worked that out ahead of time of doing the video. And then what about sample means? Sample means 3, 3.5, 5.5, 3. So all those you see, is it true? Is this the prediction true? The mean is 4 and the standard deviation 1.528. That's what the equations we're given predict would happen if I did this. So like I did it. Like I typed in over here in Excel all those sample means, and here's the standard deviation. I used the code that I'm telling you would be correct, and here's the mean, and look, it's there. Those are the numbers that were predicted to be true. Okay, all right, so like to me, not only am I showing you what is meant by a question like this that's more involved, but I'm demonstrating the truth of it. All right, and for me that would make it stick in my head a little bit more. I feel like I'd understand it better, and I would remember it better. I'd be more comfortable with it. It's still math, you know, and you might find it a little bit disagreeable, but you know, maybe your experience will be the same now that you see that I can take the prediction and then I can do a separate calculation to show that it's true. But nonetheless, this is what we mean by having a population, taking all conceivable samples of a certain size, calculating the mean of each sample, taking all those sample means and seeing what they're like. Okay, so all I want to demonstrate in this example is those concepts. We'll take a little further as we go through other videos and additional assignments in my math lab, but for now I wanted to just show you the numbers and demonstrate how it's supposed to work.